Hi, I did a video that I called the Extreme Computation, and I tried to upload it to the YouTube. I don't know what was wrong because it only uploaded like a minute of it and then it cut off. So I'm doing this all over again, but I have some new ideas, and I think that this video will be much better than the old one. Anyhow, this some of these ideas might be very novel and very new. If you heard it from here and you looked at the literature on quantum physics or the interpretation of these results and you didn't find it elsewhere, it would be a professional courtesy that you mention my name, because this would be a new concept, and I do want to get credit at least for my new ideas. Well, I don't make any money from these YouTube channel. Maybe in the future I will put like a donation page, but I certainly don't want to lose credit with other artists or scientists for a novel idea that I might have had and then just be forgotten. Anyhow, I have studied computation and mathematics, and it has been a subject that has been of a lot of interest to me, and I do think about it a lot. I used to study graduate works in fluid mechanics, and some of these ideas are from there. Basically, when you're dealing with fluid mechanics, you're really dealing with a lot of stuff going on. You really need to model the flow and the heat transfer that accompanies it in very good models, very mathematical, and also some of it is chemistry. Or if you're studying combustion, the models become far more extreme. It's just as bad, as hard as quantum physics or physical chemistry. Anyhow, what we used to do in our elementary models in fluid mechanics is to use the control volume concept, and this is entirely a reductionist method. By the way, if you understand what I'm saying, the stuff that I'm explaining, you should really congratulate yourself, because you have a good head on your shoulders and you know a lot of math and physics. But I try to keep it as simple as I can. In the control volume approach, what you would do is select a hypothetical three-dimensional control volume of dimension delta x, delta y, delta z, and you will write down all the influences that affect this hypothetical volume, like the flow in the x, y, z direction, and then coming out would be u plus du and so on, like v plus dv. And if there is heat transfer, you have to include it. If there is gravitational gradient, you have to include it. If there is electromagnetic waves going through this thing, you have to include it. If there is gravitational waves, you have to include it. This can become very complex, but basically what it will produce, it will produce sets of partial differential equations, and then you'll have some constraint equations that relate to the type of the fluid or the boundary condition from which you have to start, like the temperature at the surface of a star, or temperature at the wall, and so on. And what a lot of mathematicians would do, and this is called analytical method, is to solve this analytically by making huge simplifying assumptions. and then try to reduce these partial differential equations as much as they can, even to ordinary differential equations, and then solve them analytically, find a function of some sort that fits this. Uh, the other method, one would be Monte Carlo method, is writing these partial differential equations as difference equations, and then solving them using the computer, because you have to march in space and time, starting from a known boundary condition, and that requires a tremendous number of equations to solve, and only a computer can do it. I mean, some older texts, they have, like, you pick out 10 nodes and solve all the equations using these 10 nodes. Well, that's crap, because you really don't know what the flow is like just looking at 10 nodes. You need thousands or millions of nodes, and you're marching in time too. Anyhow, this is a little bit technical, how to solve it, and there is packages, software packages that do all that for you, and you specify the method, is it Monte Carlo or other methods, or regular difference equation solutions, or and you march from a known boundary conditions. Say you know the temperature at the surface of a star, and you march towards the center of the star in time, and so on. Or if you know the fluid flow from the inlet, you march in time and space towards the outlet. Anyhow, this is a reductionist method, and it's very successful. It has worked, and the scientists, they use it in many different situations. Well, then one could get cocky and say, okay, then if this works, and why don't I pick up my control volume and have so many influences in there, almost limitless number of influences that would describe everything that could go on in reality. And by the word reality, the physicists mean the space itself. Okay, this is not, the reality show, or this has a special meaning all the material and all the space itself in a given region of control volume. And so someone could say, okay, I'll pick out this control volume and I'll include so many influences in there that it would be impossible that there would be anything else that could go on in this reality that is not modeled by my equations, and then I'll have a tremendous computer. I'll have a crazy supercomputer, and I'll solve these. Hey, I am simulating reality, but that is crap, because I'll show you why you cannot simulate reality, no matter how many equations you write, and no matter how big and fast your computer is. It is impossible to simulate reality. Okay, there is a saying in Islamic Sufism and in other philosophies that you cannot model something that's bigger than you, something that's greater being than your own self. Okay, now I'll show you how this cannot be done with reality, because the reductionist method rely on picking out the space distances like delta x, delta y, delta z. Okay, but as the distances become smaller and smaller, because you need the smaller and smaller distances, because you included many influences, right? Electromagnetics and gravity, you're going down and down into the fabric of a space to a level where the Heisenberg uncertainty principle becomes dominant in the level of particles. Okay, so what happens is that the reductionist methods, when they sink into this lower level, they break down. And for example, Laplace, the mathematician, was saying, you give me the speed and the mass and all this about one particle, I'll tell you what will happen in so many other points in time and in space. But that doesn't work, because a particle, when they are encountering the Heisenberg uncertainty principle, the moment to moment motion of a particle and its momentum is in a fuzzy little space. If you fix the momentum, you don't know what happened to this distance where the particle is at, and so on. There are two entities that multiply together to become one Heisenberg entity. Okay, so the reductionist methods break down in this level. It's like you're coming down to a fabric over here. You're trying to enforce your reductionist methods or calculate the reactions happening here, but your whole method is going to break down. What else is happening is that all the particles that are in the fabric of space in this domain, they are entangled with every other particle in the universe, because the whole universe started from a Big Bang singularity. All these particles, they're connected to every other particle in the universe. Okay, so how are you going to write partial differential equations when you have every single particle is entangled to every other single particle in the universe? You follow what I'm saying? You can't do it. So this means that any computer that's Alan Turing kind of computer is based on reductionist philosophies and ideas. It breaks down when it tries to simulate reality, the whole fabric of reality. This is a very important and also very novel idea. Okay, I don't know if other physicists they have looked at it this way, but you cannot simulate universe. Universe is conscious. It's a consciousness. It's bigger than any kind of machine or any kind of Turing machine that's built on reductionist ideas. Okay, because the computer, it tries to break everything down into these bits and pieces and then relate all the bits and pieces to each other. But you can't. At some point, when you go down lower and lower, you cannot break it down anymore. It becomes part of the universe that's non-local. Non-local means every particle is connected to other particles, and their interactions become so complex. That's form of thinking. Okay, the other issue is that beneath a certain level, the uncertainty principle says that there is this whole set of relationships that's like biology or consciousness that will determine where the particle would go. It's just a whole vast era. It's like entering into Amazon, you know, and there's all these creatures and particles and virtual particles, and they come into play and do this and that and determine the uncertainty to make it in a certain direction. So that's why you cannot model reality. Reality is always greater, and reality or the universe itself is a computer, is a thinking machine, is an information processing machine. It is bigger than any Turing machine, and it will determine what will happen. It is actually thinking, and we are sitting here. We are a projection of this machine. We are a calculation. We are in this epoch in the singularity, and this machine tells us that, hey, in this time frame since singularity, this is the way you have to behave, okay, because this is how the projector is projecting here and now. All right, so this concept is very elemental and very valuable. On the others, on the end section of computation or extreme computation, I want to go through some projects that I think will become valuable, and they use a lot of computer time, and our new technologies or speed of computer will help us do those projects. The if human brain is constructed like the universal mind is consciousness, that also invalidates the conception that human mind is a Turing machine. Because if human mind is consciousness, is connected to this universal consciousness, then it also cannot be modeled. I mean, to some extent it can be modeled, but it is never really a greater copy than the original. The original will always have richness that the Turing machine cannot replicate. These ideas, they border onto spirituality, because if you look at what these ideas are saying, they are saying that consciousness is always greater than a calculation or a way of doing things. Anyhow, there is a verse in Quran that goes like this: if all the oceans became ink, I could not write all your beautiful names, Lord. That means that you are so rich and complex and so divine, so beyond anything that I could conceive of, that I cannot put it down. This is the same kind of way of saying that a Turing machine, it cannot replicate reality. It cannot, because it's smaller, it's a scaled down version of this greater reality. Another clue that mathematicians and logicians have had regarding this is the incompleteness theorem of Gödel. And basically it says that if you have any axiomatic system, you start with any kind of basic relationships or ideas that the most reductionists will start from, you'll always encounter problems and contradictions that you cannot solve or resolve. That's basically saying that you are looking at reality with this very coarse kind of light, and you're not seeing. You always encounter situations where you only see to some of it. You get a general clue, but when you go, you cannot go deeper. There's always more there. There's more richness, and what you have will always be this limited thing. Okay, going beyond computation, I think that if you were a scientist and you had an infinite amount of cash, like Uncle Sam, anyhow, and you wanted projects that will just totally transform humanity, that projects to die for. I mean, this. I want to talk about some of these projects that I think we should do, or instead of spending trillions of dollars in Afghanistan or Iraq or destroying other countries and ruining our own selves too. There are projects that are very worthwhile. One would be constructing a space elevator. Some of the technologies here, nanotubes, wires that are made of nanotubes are already here. And the other project that would be very expensive, very worthwhile, and in fact the Europeans are making a lot of discoveries using LHC, would be Super Collider 2.0, because we kind of screwed up the Super Collider 1.0, and that we could make a lot of discoveries, and a lot of people will get employed. A lot of good companies could benefit from it. What else is there? The other one would be to make a scanner. Basically, I don't know if they'll use ultrasound or other technologies, or kind of like a X-ray to scan like a human body or a leg in its molecular form. Like, this resolution is so small that you know molecule by molecule what's there. You follow what I'm saying? Atom by atom. And be able to store that in a computer that has like massive memory and can store all those relationships between the atoms and the molecules. This would be the first step. This is almost like sci-fi, but hey, I can imagine that, right? I mean, the other part would be to make a printer that can print in 3D, not just in a coarse manner, but as molecule by molecule, which means the print head shoots out many different atoms, and when the atoms reach the head of the printer, it will zap it with laser and put them in the right quantum state, and then combine them with other atoms to print like one molecule or one gene, and then moves on. And that it's a 3D printer that I don't know if we'll have it anytime soon, but hey, if we have a lot of cash, you can attempt to make things that are outrageous. You know, they are beyond the other project that I wish somebody would do it is like making an interferometer with like say for example there were 10,000 amateur astronomers. Each one of them had a very good computer controlled telescope, and combine them all over the earth to make a massive interferometer to look at a particular star, or which means basically resolution that's beyond anything that you can imagine. You just, you know, you can even look at the clouds on the surface of a satellite or a planet. The other projects that would be radical would be making special space telescopes. There is one that I forgot the name. That there is a circular black patch, and the light goes around it and focuses on a focal point. But the larger the patch is, the larger the circle is, the finer the resolution. But there is no limit. All you have to do is send the circular patch with scaffolding that's very big and control its motion and get a huge resolution. We could go on space telescopes that have endless. I don't know what's the limit on the resolution one can reach. The other projects that would be of interest would be political. They wouldn't be technological. One of the projects, one of the ideas would be radical democracy, and I think the United States needs to get rid of these ultra-conservative war hawks that are getting us into many foreign wars. I don't know if it will happen before something nuclear happens here, but people are very slow in learning. I hear many things that are just completely bogus, but I don't know. I will tell you about some of these other projects uh, that I think about. The other one would be encrypting everything, even communication between phones, communication between computers, massive encryption to completely shut out any kind of spying, or I mean the kind of encryption that, say, one computer is connected to the internet, almost every computer that's connected to the internet is encrypting every bit of communication this one computer is doing. Just make it almost impossible to do trapdoors, or totally bring back privacy. And taking that encryption technology and applying it to contracts, to Wall Street, to every aspect. It will completely destroy any kind of government control or centralization. I saw somebody was doing that in the program Kaiser report, but I would like to see more of it. Especially this technology should be applied to phones. The private conversations are completely private. Um, Thank you very much for being in my YouTube channel, and please leave comments and let me know. You can also email me at youractorhassan@gmail.com. It's all one word. Youractorhassan is all lowercase at gmail.com. I like to hear from you guys, and let me know if you find any of these ideas new, or should I take credit for any of them. Thank you very much.